Welcome back. This episode is part 2 in a 4-part series about the Eclipse of Darwinism. Enjoy.
There is grandeur in this view of life.
Welcome to Evolution Talk with Rick Coast, an introduction to the oldest story ever told.
What would happen if two animals that had spent their lives using their right limbs far more than their left limbs had offspring?
I'm gonna say their right limbs would be bigger.
You're right.
That exchange could easily have been conceived by Jean-Baptiste Lamarck. We met Lamarck way back in episode 23. It's quite a few episodes ago. As a sort of a quick reminder, Lamarck was a French naturalist who lived from 1744 to 1829, and he was one of the first to publicly come out and say that evolution or transmutation occurred in species and was driven by natural biological forces. Unlike the theory of evolution by natural selection, Lamarck proposed the driving force behind changes in species had everything to do with use and disuse. And to be fair, natural selection hadn't yet been conceived. At the time of Lamarck's death in 1829, Charles Darwin was still 2 years away from his 5-year voyage aboard the HMS Beagle. And Alfred Russel Wallace, well, he was only 6 years old. So, what is use and disuse, or what we know as Lamarckian evolution? For that, let's go back to the example given at the top of the episode. Now, let's say I grew up a very skinny kid, and that I came from a long line of skinny men. Say my dad was skinny, and his dad was skinny, and so on. Hoping to break this long chain of skinniness, I decide to join a gym and work out.
I lift things up and put them down.
As a result, I grow muscles.
But to be known as a weightlifter is to enjoy at least local prestige. They know that ordinary men will think twice before picking a quarrel.
When I have children, the long line of skinny men appears to be broken. My children are more robust than I am, all because they inherited traits that were developed during my lifetime. The trait of large muscles. That's Lamarckian evolution. So now, let's apply this to the animal kingdom. I could use the giraffe, which is really the poster child of Lamarckism, but instead, I'll use the blind mole. While the blind mole's skin-covered eyes are the result of a mutation which didn't inhibit the mole's ability to survive long enough to have offspring in its environment, as, well, natural selection would explain, Lamarck would say it's because the mole stopped using its eyes in the dark. Neither Darwin nor Lamarck were aware of genetic mutations. Darwin only knew that a variation had to be introduced to allow for natural selection to step in. Lamarck said it was the mole's doing. Now, because the mole lived in the dark, it stopped using its eyes, and so over the span of a few generations, it developed poor eyesight and no longer needed them. So according to Lamarck, evolution followed 4 laws. Law number 1, life has a force, and that force works to increase the size of the organs to the extent they can be increased. Law number 2, new organs, wings, or characteristics result from new requirements placed on the organism to develop. Law number 3, once acquired, the development of those new organs are up to the organism to use or basically lose. And law number 4, everything that is acquired during an organism's life is transferred to its offspring. Lamarck also acknowledged that these requirements for an organism to develop or begin to develop new organs came as a result of the environment the organism found itself in. The requirements are different if I were to live in a savanna or in a deep, very dark cave. Now, Darwin didn't come along and completely wipe out Lamarckian evolution. As I said, Darwin himself wasn't sure what caused variations to appear. He saw it as a gap, one which wouldn't be closed until science shed light on genetics and mutation. So to fill the gap, and almost reluctantly, Darwin proposed that every part of the body transmitted gemmules, which are passed on to offspring, which inherit a mix of gemmules from both parents. The way these gemmules change to introduce a variation would be if the environment causes a change in a body part, which in turn affects the gemmules. Darwin called this process pangenesis. And it's all pretty Lamarckian if you ask me. Darwin's thoughts on pangenesis were later muckled onto by the Neo-Lamarkisms during the Eclipse of Darwinism in the early 20th century. As time went on, and the study of mutation and genetics and later DNA came around, Neo-Lamarckian insight fell into disfavor. But, as was once said about Darwinism, reports of Lamarckism's demise have been highly exaggerated.
What is happening in evolutionary biology is that people are beginning to consider epigenetic variations and the inheritance of epigenetic variations as a factor in evolution.
That's Israeli geneticist Eva Jablonka. Epigenetics is the study of the environment and an organism's behavior in that environment and how it affects its genes. If these genes are inheritable, they can be passed on. Now, there is some resistance to this, especially due to its Lamarckian overtones. The reluctance to accept this is due to the fact that
the epigenetic system has a dual role. It is both a response system, epigenetic control is part of regulation of gene expression, and it is also a memory and inheritance systems.
What this is saying is that
the change epigenetic marks can be transmitted from one generation to the next, at least in theory, and it seems also in practice, because we are seeing a lot of transgeneration effects that we don't exactly know how specific they are, but sometimes they seem pretty specific, and they're inherited sometimes transiently, sometimes for many generations.
Does this fly in the face of Darwinism? Well, no. Especially not natural selection. If environmental factors can turn inheritable genes on and off and they are transferred to the organism's offspring, well, that still allows for natural selection to take over. It's no different than a mutation, at least as far as a variation in traits are concerned. Now, that being said, it still has its detractors.
Now, a lot of people do not like this. A lot of people regard it, have a kind of knee-jerk response to it. This cannot be true. We have learned in high school that this is not true. Lamarck was wrong.
It appears Lamarck may have not been that far off. Epigenetics studies the regulation of gene expression and the resulting traits, and these can be dictated by the environment the organism exists in. Some of these traits can be plastic, meaning they may or may not express dependent upon the environment. An example of this would be, say, the speckled wood butterfly, which may express either 3 or 4 dots on its hind wings depending on the environment. Diet and temperature can also affect phenotypic traits. This can be selected for by nature, and phenotypic traits often are with artificial selection or breeding. In a TEDx talk, geneticist Moshe Schiff had this to say about an epigenetic study with rats.
We thought, is it possible that the mother is somehow reprogramming the gene of her offspring through her behavior?
Moshe and his team spent 10 years pursuing this question.
And we found that there is a cascade of biochemical events by which the licking and grooming of the mother, the care of the mother, is translated to biochemical signals that go into the nucleus and into the DNA and program it differently.
Now, this allows for the offspring to prepare for the life it has in front of it. Will it be, say, rife with danger, or will it be relatively comfortable? There's more to genes than meets the eye. What you see in a gene today may not be true tomorrow. For example, let's look at crocodiles. This was explained wonderfully in a talk given by British biologist Nessa Carey, the author of the book The Epigenetics Revolution. As she explains it, if I were to take DNA from a male and a female human, mix them up, and then analyze them, I would be able to tell which came from the male and which from the female simply by the presence of the Y chromosome, which males have. Do the same with DNA from a male and female crocodile, and we wouldn't be able to say which was which no matter how closely we studied it. And this is why.
In crocodiles, Gender is not determined by genetics, it's determined by the temperature at which the eggs develop. Yes, which could be a very odd consequence of global warming. We will see a skewing in crocodile populations, just to add to all the other worries, right?
Lamarck focused on an animal's use and disuse of organs and body parts, and the inheritance of that behavior. Today, use and disuse is tossed aside and the focus falls in genes and their expression dependent upon the environmental factors. While it once sought to override Darwin and natural selection, well, it's now part of the natural scheme beneath the overarching umbrella that is natural selection. I hope you enjoyed today's episode of Evolution Talk. I'm Rick Coast, and you can find show notes and source material and ways to support the show at evolutiontalk.com. Links to get there are in the episode notes. You can also find ways to contact me at the site. I'd love to hear from you. I hope your week is going well, and until next time, please take care of yourself.
Evolution Talk is a Rick Coast production.